Again, I'd like to thank everybody for coming to the first session of 2015. Again, this session is going to focus on the Unity sleeveless elevated vacuum system. We are going to go through and review the transtibial elements of the system and how it works, as well as what's really new now is that we have the system available for transfemoral amputees with a number of different knee systems as well. So we'll go through all the different components, how those fit together, and indications and contraindications, obviously, for use and how we can make one of these systems from start to finish. Just to go through briefly the general advantages of vacuum suspension that have been found over the years. It is a very firm suspension system that provides excellent security and improved proprioception compared to any other suspension system that's out there. It's going to be the system that most closely simulates something towards a direct skeletal connection without going to the osseointegration level. Elevated vacuum, we know, tends to assist in maintaining more constant limb volume for individuals, and thus it in some cases eliminates the need to add socks, but for most individuals it will greatly decrease the amount of socks and frequency that socks need to be used throughout the day. Elevated vacuum also has been found to assist with wound healing. We found that with our system and with other systems that are out there, that folks that have chronic wounds, that elevated vacuum tends to improve circulation. It tends to help that tissue to heal itself and return a bit more towards a more normal, supple state. We also know that it's a very comfortable system for people. So even folks that have bony residual limbs or folks that have a lot of redundant tissue, they find that it's a very, very comfortable socket fit, like a cushion system, but even more comfortable than that in many cases, particularly because the suspension is so much more positive and the proprioception is so much better. So we have very, very accurate volume and length matching methods that we use to get these sockets right. What I'd like to put out for you today is just for your own consideration and something to perhaps think about in the background of your mind. It's perhaps maybe a question more than anything else. I think that the perception in many markets around the world still is that elevated vacuum is a nice to have versus a need to have for an individual. But there are some studies out there that point to elevated vacuum in terms of being more medically necessary for the individual. So for example, Board et al. In 2001, they found that basically daily volume changes were contributing to poor socket fit and pistoning or motion between the residual limb and the interface, creating a loss of proprioception and some insecurity in gait. So that control of volume is rather more of a necessity than a nice to have in the system. There's also been some evidence to suggest the activity-specific balance confidence scales, the ABC tests, have been found in a study to be significantly higher in participants using vacuum suspension compared to other systems, indicating a lower predicted incidence of future falls. So we know that if we can reduce the incidence or potential for fall risk, that's a huge safety issue for a lot of people. Transtibial and especially transfemoral. So if we can improve that somehow, and we can do that through the suspension system, then why not employ that as a need to have? Skin problems, breakdown and blistering seem to be decreased in vacuum users, and walking times increased for some users, so indicating also an increase in someone's mobility level. And then additional evidence that is out there to support our claims of volume control being a positive attribute and more of a necessity than not in a prosthesis is that these are some study references for you. They found that vacuum-assisted socket has been shown to eliminate daily volume loss, as we mentioned before. The vacuum assist ensures a good fit during the day in ambulatory transtibial traumatic amputees with mature stones. The combination of reduced pistoning and maintenance of volume is thought to account for more symmetrical gait patterns And elevated vacuum suspension systems have managed volume fluctuation, a problem that people with limb loss are challenged with. So these are just some additional studies that you could reference as evidence for controlling, successfully controlling volume with elevated vacuum systems. And another study that's given us some evidence addressing fit, comfort, and limb health. Sanders found that when limb volume decreases, the socket is loose fitting, obviously, and causing pressure to bony prominences, which may result in pain or injury to the limb. So again, using elevated vacuum helps to, and has been shown to, decrease or eliminate a lot of these problems. So perhaps why not consider it to be a necessity compared to sort of a nice to have in the prosthesis. So hopefully these are references that can help you in terms of applying for funding perhaps for elevated vacuum systems and arguments and evidence to use with the prescribers out there. Primary benefits that we found with the Unity system itself compared to other systems that are on the market is that A, it's a sleeveless system. For transtibial amputees, we don't have to have use of a suspension sleeve because we're using the seal-in systems integrated with this. This really helps folks get increased knee flexion range. Also, it's easier to achieve knee flexion because you don't have the buildup of negative pressure that happens underneath the sleeve and makes it difficult to bend the knee. So they can bend the knee with greater comfort. It's better long-term acceptance. You'll see down the list there's also increased reliability. That also relates to the sleeves, that we have a minimized risk of leaks and punctures associated with the sleeves that we typically use with these systems. It's a lightweight and discreet system. This has been particularly attractive to a lot of people out there, users and prosthetists, that it's only 130 grams added to the prosthesis and everything is housed within the foot shell. So there's no extra added weight or bulk to the prosthesis itself. It's a simple and efficient pump, and we're going to break down the pump later and show you kind of piece by piece what it's composed of. It's very simple and efficient. It's quick and easy to elevate and release vacuum levels and elevate those levels within a few steps. It's an independent pump, so we don't rely on any particular shock absorber mechanism or anything like that to elevate the vacuum. We're simply using a small amount of heel deflection from the flex foot, and we're harnessing that with the pump and using that to draw air out of the socket. We get the volume stabilization that we mentioned before, which is going to optimize socket stability, proprioception, and comfort. And we've had the system obviously integrated into a number of different flex feet. So we're going to go through all the flex feet that are available now with Unity. And I think you'll see that that's going to serve quite a wide range of clients that are out there. In terms of candidate profiling, now that we've made this for transfemoral users as well, we're looking at transtibial and transfemoral amputees anywhere from low to high impact levels. The weight limit is going to be entirely based upon the recommended foot and knee module itself. So Unity is not a load-bearing structure in any way. It's just harnessing, again, a little bit of that heel deflection from the flex foot. So you're going to choose your knee units and your feet as you would usually according to weight limits and needs of the individual. We do need sufficient length to use the seal-in V for transtibial and the seal-in X for transfemoral. We have found that very conical residual limbs can also be fit with Unity. In many cases, for the extremely conical limbs, you may want to use a distal cup. But it is possible to get these folks fit comfortably and get the system working with a distal cup. The contraindications for use as we see it at the moment are very short residual limbs where we can't fit the seal-in V or the seal-in X. There's just not enough length to get that seal buried safely in the socket. Or when total contact cannot be maintained distally between the liner and the limb. That's a big no-no with any vacuum system. We've got to make sure that there's total contact, especially distally, so those tissues aren't damaged in any way. Deep invaginations, deep scarring, we've got to find a way to fill those areas, or we've got to find another system to use. Also, if you're expecting significant volume changes happening in the short term, we'd suggest that you possibly consider using another system. The basic building blocks of the Unity system, we're using proven sealant technology. For the trans-TIBs, we're using sealant B. For the transfems, we're using sealant X. And we'll go through each of those systems in a bit more detail shortly. The socket connection is going to be a Unity trifunction valve. And the Unity system for transfemoral is going to include some special keepers and special reinforced tubing kit that we'll go over in a little bit for the transfemorals. In terms of feet, we have the Reflex series, so Reflex Rotate and Shock, LP Rotate, the Veriflex series, low profile Veriflex and standard Veriflex, Proprio, which can be used by itself for trans-tib or with the symbiotic leg for transfemoral, and the balance foot. And obviously the vacuum pump mechanism is attached, the Unity pump, to the flex foot. What I'd like to review with you guys now is just the sealant V itself. It's been a while since we've reviewed this with everybody, and this has been a very successful interface to use. It was designed specifically for use with transtibial vacuum systems, but people have also been extremely successful with this using it for straight expulsion fits. So I'd encourage you to think about it for straight expulsion if you haven't used it for that purpose yet. It uses a dual sealing membrane, which gives you that redundancy of seal that you see, and you're probably familiar with the X5 liners. And we also have with this one, you'll see the volume adaptive blades that tend to accommodate well for volume changes. They help press that seal out against the socket wall to give some counter pressure in the case of any volume loss whatsoever. It keeps that seal pressed against the wall. So for your expulsion fits, that's very, very helpful. You don't find that people need to add socks straight away if there's a volume loss. That's going to give quite a bit more forgiveness and security with those fittings. For vacuum users, what's fantastic about those blades is that it creates kind of an I-beam effect under vacuum. So it prevents that seal from folding and buckling on itself under vacuum. That's what makes this particularly successful compared to other sealants, the redundancy of the seals and the blades. We're using dermogel silicone, so soft silicone with this. And the other obvious thing that you'll see is that we have two different seal heights available. So obviously that's fantastic for optimizing the amount of surface area we can get under vacuum or under suction within the socket. Compared to other tip sealant systems, compared to the HSM, the second seal, again, is going to increase security comparatively. So, with the HSM systems, we just have that single seal. So it's very easy to have the system leak potentially with a single seal. Having that second seal is really going to increase that security of the system. It's also going to be less prone to fold or buckle, and we're going to get substantially better rotational control out of the system. Compared to the X5, it's more forgiving. It's a more forgiving fit with respect to the shear force distributed around the seal. It's also going to be more forgiving in terms of volume loss, that we can use socks tucked underneath the seal up to 8 ply. And we get a lot better seal retention with respect to tissue movement. For example, with the X5, you know that when the tissues contract, we get deflection of the seal, which can pull away from the wall. So we tend to find with the sealant V that we retain the seal retention much better, even with muscular contractions inside the socket. In terms of sizing and fitting, with the sealant V, we're measuring the circumference 4 centimeters from the distal end of the soft tissues, and we're selecting the size that matches or just below. If you're between sizes, you go to the size below. If you're choosing a high-profile seal or the standard seal height, that's going to be completely dependent on limb length, which we're going to go over in a moment. So basic sizing with this is exactly what you would do for our locking liner systems or our cushion liner systems. I mentioned previously, there are different minimum seal requirements depending on limb length and size. So you don't have a fixed seal height. It does vary a little bit depending on size of the liner. So that's why it's really important to reference these charts that we've got here. My one piece of advice to you would be to look at the residual limb length from mid-patellar tendon to the distal end. Take that length and subtract 2 centimeters, and then reference these charts. By subtracting that 2 centimeters, it gives you kind of an actual length of the limb that you can work with. And the reason I say subtract 2 centimeters is to account for that medial hamstring. You're always going to drop the posterior wall of the socket about 2 or potentially more centimeters from MPT. So that gives you a pretty good rule of thumb once you reference these charts in terms of the actual residual limb length that you have to work with. And then when you fit the liner, you're going to have a good degree of confidence that that seal can be buried within the socket wall safely. The seal in V. For the seal in X, for those of you that were at AOPA last year, this is where we introduced the seal in X to the market. It's been extremely successful and has taken off quite quick in terms of people using this for their transfemoral expulsion fits. I think the reason for that is obvious, that having a modular seal-in system has been something that people have been asking for since 2003 when we introduced seal-in liners for the first time. So now that we have a modular seal that we can work with, it's fantastic clinically because we can address all these issues with shape or tissue sensitivity, tissue consistency, skin condition issues, where having a fixed seal on the system, we're not able to move that sealing membrane away from those troublesome areas at times. And now we have the ability to do that. We can move that seal wherever we'd like. And the other obvious advantage is that we can move the seal more proximal to put more of the limb under vacuum or under suction, and that's going to be fantastic to optimize suspension. We still have the standard and conical profiles available. This liner is slightly stiffer compared to the other Transfem liners we've had to give better stability to the proximal tissues and support. You'll also note with this one that it's thinner distally. Folks have found that more positive in terms of giving better conformance to the limb shape, as well as giving a little bit better proprioceptive feedback, not having so much thickness at the very bottom. If you do have folks that have a sensitive distal end, I've addressed that in some fittings by using distal pads that are laminated into the bottom of the socket so that they can still have that additional cushioning if they like that. Another plus with this one is that the textile cover has been enhanced. It has twice the adhesion strength and abrasion resistance compared to our existing range. And this is something I'm very hoping will be employed in the other liners that we have to give better durability over time for the user. In terms of the mechanics of the seal in X, this is a question we get pretty frequently, is how does it work that we can use a modular seal on the outside of a textile covered liner? Well, what you'll see on the seal in X is that you have a series of seal bands that are made of silicone and that basically impregnate the textile and contact the silicone wall on the inside. So we're able to retain basically a seal from outside to inside with the use of those seal bands. And we recommend that you place the modular seal over at least 2 of these bands. So again, you have redundancy of seal between the seal itself and the liner. Basically, that's providing a seal bridge to the inner socket wall. And again, those bands are passing through the fabric and bonding to the inner silicone. The seal itself is a modular seal. The seal ring is using the volume adaptive blades, similar type of principle that we see with the seal in V. You can see the same redundancy of the radial seals as well. So we've got 2 radial seals, we've got the volume adaptive blades, and those volume adaptive blades are going to keep pressing that seal against the inner surface of the socket wall. So even with a little bit of volume change, that seal is constantly trying to press up against that wall to retain seal. And again, with the blades, that's also going to help us when it's under vacuum to prevent any kind of buckling of the seal. Similar principles, again, as we see with the seal in B. X is also 5 centimeters longer than our previous transfemoral liner models. And that's also been a request from the markets for a number of years now. So it's great to have a liner that's a bit longer for limbs that are longer and need that extra length and containment of proximal tissues. The seal bands themselves are about 25 mils apart. Again, we recommend that you place the ring over 2 seal bands. You have that redundancy of seal of the seal ring itself against the liner. So you should basically see one seal band just below and just above the seal ring when you've got it fitted to the client. The sizing and profiling, used to using our transfemoral liners, really things aren't too different in terms of liner sizing at all. So you're going to define whether the limb is in the proximal third relative to the sound side, the middle third, or the distal third to figure out profiling. You'll take your distal circumference 4 centimeters from the distal end and then a perineal circumference as well and determine your profile. In terms of sizing, you're going to pick the size that matches your 4 centimeter circumference measurement or just the size below if you're between sizes. The other thing to learn about, if you haven't learned about this already, is the seal ring sizing. So if there's anything tricky about the seal in X, it's the seal ring sizing. And really, it's only tricky that it's a new thing. So once you get used to this and do it a few times, it's very simple. The big thing is to decide where you want to place the seal ring on the limb itself. And we'd recommend that you place this at least 10 to 15 centimeters below the perineum. That's, again, so you can get that seal buried within the socket wall appropriately. The seal is quite wide, so you need a bit of room to be able to do that. I'm going to take a circumference measurement directly over the limb where the lower edge of the seal is expected to rest. So you're going to take that just directly over the limb itself, not over the liner. Okay. You're going to choose the closest seal ring size to the measurement. And if you're between sizes, go to the smaller size. For many fittings, folks have been finding that they need to go down 1 ring size. And so don't be afraid to downsize a little bit on the ring. Most people have been finding that that works quite well. Once you get the liner on the limb and you get the seal over the liner on the person, you can check and get a visual to see if the tension is going to be correct. So have a look at these pictures. What you want is the ring to be where you want it on the limb without deforming the shape of the limb. If you're finding that the seal is cranking down on the limb and deforming the shape, it's probably going to be uncomfortable and you're probably going to have issues with it sealing appropriately. So you want the ring to sit rather flush and not distort shape. We're going to use this the Unity trifunction valve. We're going to use this for transtibial and transfemoral actually. So this is an expulsion setup, but it also has a vacuum bypass added to it. So you see it looks very familiar, looks very similar to our 551 valve, but we've added that vacuum bypass function obviously so we can use it with Unity. And then there's also obviously a release button incorporated so that somebody can get in and out of the system using the seal and liners. With these valves, I'd highly recommend to you that you take them completely apart before you do any trimming. The metal shavings, if these are caught in the duckbill valves and the seals, are really no good. So it's best to make sure you disassemble this completely before you start cutting or trimming things. And make sure they're cleaned out very well before you finish your fitting and send somebody off. Okay. It's also very important that the system is sealed internally and externally. So we have had folks forget to use the inner dummy. There's a white dummy that we need to use to basically lock this valve into the socket wall itself. Typically with the 551 valves, most people don't use these except on flexible sockets. But with the Unity system, it's really a necessity. We need to have that dummy insert used on all the sockets and seal that with silicone on the internal wall and then seal the valve housing to the external wall so that you've got that redundancy of seal, and it really helps you to reduce the incidence of leaks with vacuum. You can use the Selleys glass silicone sealant, which is a fantastic local product to use with this. The only other recommendation we give you with the valves is to avoid lateral placement on the socket just so it doesn't get knocked up against anything. So most people are placing valve cores on the anterior medial aspect of the limb. That's on transtib, transfem. On transtibials, maybe also posteriorly is another good placement. Okay. You can see here just an assembly of the transfemoral kit on a socket. Now this was one that I retrofit onto an existing socket to trial it. So don't misunderstand from the photo that you need to use a 552 valve in conjunction with the unity valve. For you guys, doing your check socket fits with just the unity valve is fine. Okay, so again, this is one that I was just retrofitting up to assemble it and trial it together with a RIO. Okay, so the transfemoral kits, the tri-function valve, and you have a series of plastic and rubber keepers, as well as a reinforced tube to use for the transfemoral. The reinforced tube has a nylon reinforcement around the knee. It's referred to a nickname called snakeskin reinforcement. This is a reinforcement that's typically used for electrical cabling. It's very tough. It provides extra resistance to kinks and abrasions and tears, obviously, that we wouldn't want. And it makes sense to have that around the knee where you have a lot of flexion and extension motion happening. And again, those clamps and elastic keepers are helping to keep that tubing run nice and neat from the foot all the way up to the socket connection so that we eliminate chance of snags and things like that happening to the tubing. There are two different transfemoral kits with the valves and the tubing. The main kit that you'll probably be using in the beginning is the one that includes the tri-function valve, so the UTF-0001. That gives you the tubing, it gives you all the keepers you need, and the tri-function valve. There's also a kit available that just gives you the tubing and the accessories, and that might be something more for down the road if somebody needs tubing or keepers replaced and things like that. So that's a secondary accessory kit that's available too. I just wanted to go through a bit about the integrated unity pump and how it's attached to the flex foot. Well, I think a lot of you have been exposed to this, but I think it's good to go over it again. And I'm going to run through a little bit of a picture show to show the different parts and pieces, how they assemble and disassemble. The number one label on there is the frame and support blade. So all the flex feet have a particular support blade that the unity attaches to. So again, the unity is not a load-bearing structure. It's just harnessing that heel deflection, and it does that by using counterforce against the support blade. The check valves are there to basically make sure that air is drawn out of the socket only one direction. Those check valves are just simple duckbill valves, and I'll show you those in a moment, that are inserted into the unity housing there. The heel pad is basically there to provide that counterforce against the heel itself. And then the membrane is actually what does a lot of the work. When it deflects, it's going to draw air out of the socket. So what I'm going to do is just stop out of this for a moment and show you a few photos. Okay. And I think there's one of the interesting things about Unity is the simplicity of the system, and it is wonderful to maintain in the field. It's very easy to take the system apart, to clean it with isopropyl alcohol, replace anything you need. Everything can be field maintenance. So this is just a photo of the Unity pump upside down. It shows the button that basically keys into the support blade and the membrane seated in the Unity housing here. Okay. And what a lot of people don't know is that that membrane itself, it's nothing that inflates. All it does is pull slightly out of the housing and draw air out of the socket. So it's just it's a flat piece of thick rubber that basically inserts into that circular slot there. and when it's deflected, it pulls air out of the system. So it's a very, very simple thing. So if you ever needed to replace the membrane, it's as simple as popping that out and popping a new one in. And it's very tough, very thick rubber piece there that's pretty hard to destroy. Okay. Just to take a look then at the barbs. The barbs are remove the exhaust port itself and the intake port there. These are removed with an 8mm crescent wrench. Okay. And we do, for a lot of folks, when we do courses, we give you a toolkit that has all the basic tools, the 8mm wrench, and some needle nose pliers, and other bits and pieces, other accessories and things like that, including fitting pads that are very useful to get started. So that's what we give you when you take our course with us. Okay. But the barbs, when we pull them out, so this is just a look at the exhaust port when it's pulled out. You can see the small duckbill valve seated on the exhaust port and how that would fit into the Unity system. We can pull that small duckbill out. Okay, let's just take a look at that here. You can see that small duckbill valve, okay, that just sits inside, okay, right on top of that exhaust port. Okay, so very simple to clean, put back together, and then reinstall into the Unity housing. Same thing if we look at the intake port with the barb there. You can see the duckbill sitting on top, and that just slots into the housing there. Okay. So these would be all the Unity pump itself completely disassembled with the exhaust port, the intake port, and the membrane completely removed. So again, very easy. We recommend cleaning it with isopropyl alcohol, and then reassembling is very quick to do. It just takes a few minutes. Okay. Just to look at the support blade, again, that keyed slot, that's where the Unity pump slots in and then attaches here with the threaded attachment here. And then obviously the heel pad would attach to the back section. Okay, so if anything would ever happen to the support blade that becomes damaged, we'd replace the entire foot for you. Okay, no questions asked. All right, so hopefully that gives you kind of a quick and easy look at the entire Unity pump system itself and how easy that is to take apart and maintain. Okay. Fitting the flex foot itself with Unity is no different from what you're used to already. We just select our size, we select our category and model as you would with any other system. So there's nothing special you have to do. Maintain your good static alignment, follow those flex foot principles that we've always taught. You can still use the heel wedges with this system. It may take the user just a few more steps to get up to maximum vacuum, but you're going to want to dial that heel wedge in as you would normally to make sure that you get good dynamic function and control of the foot. The pump's going to elevate vacuum up to -22 inches of mercury maximum. The typical operating pressures are somewhere between -16 and -20. And again, the added weight to the system is about 130 grams. Again, I'll say it again, we recommend running the tube and the valve medially to avoid impact with foreign objects. And another interesting reminder for you is that all of the Unity pumps come out of the box set up for a left foot. But just as I showed you in the photos before, you can remove those ports with the duckbill valves, and you can swap them for left or right. Okay, so it's just a matter of exchanging the ports one side to the other. It's the same threaded setup. Okay, so very easy to switch. There's a knee and foot compatibility with Unity. We have everything now available from low, moderate, and high impact systems. So if you have the balance foot, again, we have the LP Veriflex and LP Rotate series, Veriflex, the Reflex series for your high impact individuals, and Propria that can be used transtibulally by itself or transfemorally with the symbiotic leg. In terms of knee systems, all of our knee systems can work with this, from our manual locking knee joint, the balance knee system, all the total knee range and mount, and obviously Rio and the symbiotic leg. Now to go over some bits about casting and modification. Okay? We're still sticking with the recommendations. If you've learned about transtibial Unity before, the same recommendations we're recommending now as well. For casting, just to take your circumferences and an ml dimension around the knee. You should take a neutral cast using elastic bandage and rigid. The elastic is basically going to give you just the right amount of pre-tension longitudinally on the limb that you need so that you don't need to add any extra compression with your hands. You're going to do a proximal to distal wrap with a little bit of knee flexion. And again, avoid tightening the cast or making any kind of distortion to limb shape. All you're looking for is an exact copy of what's sitting there resting in front of you. We don't necessarily recommend casting with vacuum. However, if you're used to casting with vacuum and that's your habit and you like to do that, we haven't found that it's a problem. So if you want to continue doing things that way, that's all right. We just haven't found that it's added any extra value to what the fitting ends up to be for the client. So it's a little bit of extra work, but if you like to do things that way, that's fine. In terms of modification, you're going to correct the ML dimension, level out the seal area, do a global 3 to 5% volume reduction from the patient measurements. When I teach the course, I recommend everybody start at about 4%, and that seems to be a pretty good value for most individuals. There are even folks that you'll find go upwards as high as 6%, but 3 to 5 is a pretty good place to start. And then we remove up to 6 millimeters of material distally on the model. Again, remember to make sure you use the valve dummy attachment before you pull the check socket, and especially before you make your definitive socket. Evaluate the check socket. It's ideal to place the seal on the transtibial level as high as possible. So in the photos here, you can see the high-profile seal used and how that seats just below the posterior trim line there. Again, it's ideal to have about 1 to 2 centimeters between the top of the seal and the posterior trim line. Sometimes it's a luxury to have that much room, so you have to use your clinical judgment to decide how much you can get away with there. Sometimes you only have a few millimeters, and you find that still works, but it's ideal to get that buried as deep as you can within the socket wall. When you read the pressures on the seal in V against the socket wall, it's ideal to see what looks like almost a tire track, a four-wheel drive tire track against the socket wall. That's what you really want to see. If you're not seeing that impression against the wall, it probably means you don't have enough compression, that the socket's a bit too loose. So that's a good way to read that. If you're not seeing that track up against the wall like that, you need to probably tighten up your socket circumferentially or in that particular area to get a bit better fit. In terms of transfemoral casting and modification, with the seal in X, we're recommending a simple standard plaster cast. You don't necessarily need to cast over the seal ring. The fittings that I've done, I haven't cast over the ring, I've just cast over the liner itself. However, clinicians have also been successful casting over the ring. You just got to make sure it's a little bit more work to remove the impression once you do your modification. So if you like doing things that way, that's fine. You can do that as well. The elastic plaster, especially up around your proximal rim, is quite helpful. We've found that gives a bit better retention of the natural shape of the limb, and then using rigid over top. Another little tip with the transfemorals is to avoid any kind of excessive proximal weight bearing. So I don't want to tell you not to fit a quad, but try not to get so aggressive with the proximal weight bearing on the socket. The reason is, once you draw vacuum on the system, you want to allow the limb to draw down a little deeper into the socket. So if they're hanging up on the proximal brim a little too much, you might get some uncomfortable pressure along the length of the limb, or particularly at the distal end. So you want to allow a little forgiveness that they can kind of be drawn down deeper into the socket with the activation of the vacuum. Okay. The official recommendation we've been given in terms of modification reductions is to reduce to the midpoint between loose and tight circumferential measures. Okay. That's one way to do things. We've also found success with these, if you like working off, which most people like to, off of a percentage reduction. we have found that doing a 3 to 5% proximal reduction down to about 1% distal has also worked quite well. So if that makes you more comfortable to reduce that way, you can try that as well. So a couple different ways to do things. And then reducing up to 6 millimeters distally on the positive. For your check socket fitting, very important thing with the seal in X is that you lubricate the seal very well. Because this is a modular seal, if it's not lubricated well, it can stick and hang up on the socket wall and then fold or buckle during donning. So you really want to lubricate that seal well so it sits where it's supposed to on the liner and limb and gets seated where it's supposed to in the socket. Once it's in there, that's really what you should see, like these pictures here. You should see a nice seal pressed up against that wall. You should have good contact of the seal against the wall during weight bearing, obviously, but also when you apply negative force. And don't forget to check what happens when the person sits and deep hip flexion. Deep hip flexion is where a lot of people can pop suction. So always make sure that you check those things. Pressure on the seal can be read, as we would with a lot of our seal-in liners. So what you want to see is on that extension of the lip of the seal, you want to see that pressed up nice and hard against the socket wall, nice and flat. The area just above and below that seal itself might not have contact, and that's okay. But you want to make sure that extension, that lip of the seal, is pressed up tight against the wall there. Finally, whether it's transtibial or transfemoral, it's important to do a few more socket fit checks. Now, these are checks that a lot of people have found, don't feel like they need to do. And in the beginning, I suppose I felt that way as well with these. But it's really helpful to do these two checks for distal volume and also for circumferential volume. And it doesn't take you very much time, and it gives you a lot of information about what's going on with the socket. So what you want to do first is to check distal volume. And what we recommend to you to do is to use these silicone spots that we have available. Again, we supply these with the little fit kits when we teach the course. You can also get these from Evolution Industries as well. They're just little silicone spots. And you place one of these in the bottom of the socket, and you see if the client feels that it's better, worse, or the same. And what you're looking for is for things to move, obviously, into the better place. What you'll be surprised about at times is that maybe you didn't reduce enough off the bottom of the model, and you find that your socket's a bit too long. Okay, so that's really what the spot's going to tell you, is if your length is appropriate for that user. A lot of folks, they won't be able to tell you whether the socket's right or wrong, and they might feel like it's okay in the office walking around. But once you put the spots in, you're really going to know whether you nailed it or not. And a lot of times you're surprised to find that you need to use one of these spots. Circumferential volume check you're going to do with socks. Now, the official recommendation is just to use a full sock and to have somebody statically stand in the socket and see if it feels better or worse or the same. The issue I have with the static test is it just doesn't tell you enough information. So what I've been doing is using half socks. So I just, wherever the seal sits, I'll cut socks in half. I have a box full of different half socks now, and I just fit the half socks top and bottom and see what feels better, worse, or the same, and how the fit improves. And check it dynamically with the seal pressing against the wall and suction and vacuum activated. It's the only way that you really know whether things are improved or not, is if you're dynamically testing it. Whatever the result is, I'd recommend that you send somebody out with the spots, with the half socks. Send them out for at least a week on the system. Make sure that everything's working, because what happens with Unity and other vacuum systems, you just don't know enough feedback walking around in the office for an hour. Everything tends to feel good. So you need to send somebody out with the different half socks, the spots, let them try it for a week. Let them come back and see what adjustments really need to be made. Find out, what the ply difference is, what the length difference is, and make those corrections on the model at that point. I know a lot of us want to rush and kind of get through the fitting process and get somebody done and out onto that definitive. But I think you'll find that if you rush through the process with Unity, you may end up wasting more time and socket materials and so on down the road. So take your time and work through it step by step. In terms of the definitive socket structure, you're always going to use a PETG layer over the positive, again, with the valve dummy attached to the positive. So don't forget that valve dummy. The reason you need to use a plastic PETG layer is if you're familiar with vacuum already, you know that laminate always leaks. That's the problem. Laminate can work okay for expulsion setups, but it's always going to leak with vacuum. So you need that plastic inner layer. It's vital. And in terms of identification of socket leaks, there's more or less three big culprits where you can get leaks with vacuum systems. Across the seal itself, okay, when walking. So make sure you do those fit checks and make sure that you've got a good seal retained. Use of the lubricant spray is a really nice way to tell whether you've got a small leak. I use that. Just use some extra lubricant spray, and if you think you've got a leak around the seal, generally speaking, when you apply a negative force, you'll start to see air bubbles around that leaky spot. Sometimes it's just because you got a small seam pulled in your plastic, believe it or not. It can be a tiny little seam that's pulled there, and that can be what's creating the leak. So make sure you don't have a leak across the seal. Make sure you don't have a leak through the seal. On an older seal, maybe it was damaged, and all it takes is a pinhole to create a leak. And so that's another spot. Also, the main culprit I see most frequently is across the valve seat itself. So remember to use that threaded insert, seal it from the inside and out with silicone, and yeah, you should be good to go. Also, make sure that your silicone is cured before you start using the system. If it's not cured, you can also potentially leak. Last but not least, in terms of leaks, the other thing that you'll see over time with vacuum systems is that tubing, especially around barbed connections, can create little leaky spots. So always make sure to check your tubing over the long term. In terms of warranty and maintenance, the standard FlexFoot warranties apply to the foot module, and the Unity pump kits carry a 24-month warranty, the membrane itself 12 months, the sealant B&X 6-month warranties. Again, the Unity is completely field serviceable. As I hope you can see from the presentation, we can completely disassemble, clean individual components, and replace as needed. And we do have maintenance kits that are available, which supply you with membranes, check valves, barbs, tubing, all the bits and pieces you need to maintain the system over time. Again, if you take our course with us, we give you these little toolbox kits, and a lot of that stuff is included, so you have kind of a small supply of that stuff to work with from the beginning. In terms of support you have from us here, we're not saying officially that you have to have a training certification from us to fit the Unity system. However, at the same time, I would encourage you to get some support on the first 1 or 2 fittings. Potentially starting with transtibial first if you can, because it's a little bit simpler. But I think you'll find the transfemoral systems are also quite simple. There's not a lot of added complexity to the transfemoral fit out. Just let Chris know if you'd like a Unity training at your facility, or even if you'd like to come here for a course sometime, just let us know. Contact Chris, and we'll try to sort it out with you. We have order forms, transtibial and transfemoral, for Unity specifically, that are online, and fax versions available. The transfemoral is just awaiting print right now. And we have a transfemoral Unity brochure that's available online. It was actually attached to the e-letter. And that's awaiting print at the moment as well. You'll find a complete listing of all the Unity system components in the 2015 catalog supplement, which has just gone out, that you should be receiving in the mail. So that's got all of our product additions from the previous year and so on to add, and hopefully it's easy now to reference everything there. If you have any difficulties or you find Unity in any way complex to order, just please feel free to let Chris or myself know so we can help you, or customer service can help you as well to place the orders. Okay, so I think we'll stick around for a few more minutes for questions. I really want to thank everybody again for attending the first webinar of 2015. Thanks so much for spending your time with us, and I hope it was of good value. And please just let us know what we can do for you, and if you have any questions today, we'll stick around probably for another 8 minutes till about 11 o'clock this time. Thanks, everybody.